Hello students, today I am going to discuss about electrophilic substitution reactions. Those reactions in which new electrophile substitute old electrophile are called electrophilic substitution reactions. Both Friedel-Crafts alkylation and Friedel-Crafts acylation comes under electrophilic substitution reactions. Okay. So in this video I am going to discuss about Friedel-Crafts alkylation of haloarenes. When chlorobenzene is treated with CH3Cl in presence of anhydrous AlCl3, which act as Lewis acid in this reaction, 2-chlorotoluene or 4-chlorotoluene will produce. Why 2-chlorotoluene? Because when benzene ring is attached to CH3 methyl group is called toluene. So 1 2, this one is 2-chlorotoluene and this one is 4-chlorotoluene. So in Friedel-Crafts alkylation, this alkyl group attached to ortho or para position, because halogens are ortho or para directing groups. Those groups which always increases electron density of benzene ring are called ortho और para directing group. वो सारे ग्रुप जो बेंजीन रिंग की इलेक्ट्रॉन डेंसिटी को इंक्रीज करते हैं ऑर्थो और पैरा डायरेक्टिंग ग्रुप कहे जाते हैं. इट मीन्स उनमें इलेक्ट्रोफाइल ऑर्थो और पैरा पोजीशन पे अटैच होते हैं. In case of Friedel-Crafts alkylation, your alkyl group is attached at ortho or para position. So this one is your example of Friedel-Crafts alkylation of chlorobenzene. Now you can see the mechanism. In Friedel-Crafts alkylation, in first step, CH3Cl methyl chloride reacts with AlCl3. Here AlCl3 acts as Lewis acid. So octet is not complete for this Lewis acid. So it will take Cl negative ions and produce AlCl4 negative. So CH3 group will give its electron to chloride ion, so CH3 positive. This one is your electrophile, means electron deficient species. Now your electrophile in another step can attack at ortho position or at para position. If CH3 positive, this electrophile will attack on ortho position, orthochlorotoluene will produce. If it will attack on para position, para-chlorotoluene will produce. Okay, so CH3 positive is your electrophile in case of Friedel-Crafts alkylation. So in Friedel-Crafts alkylation, alkyl group it is attached to ortho or para position. This CH3 positive will attack on this carbon. Here these bonds comes at this carbon. Now negative will takes place and here positive charge will takes place. But CH3 positive, which is an example of electron deficient species, will attack. So it will take these negative electrons and CH3 will combine to this benzene ring and electron deficiency will produce at this carbon. Now these electrons comes to this positive charge and this positive charge come to other carbon, and again in this species these pi electrons come to electron deficient center and this positive charge come to this carbon. All these three structures are resonating structures. Now in last step, your hydrogen donate its electron and aromaticity will produce, and proton will hydrogen will remove in the form of proton and orthochlorotoluene will produce. And in the last step, your proton again react with AlCl4 negative and here दिस प्रोटोन टेक Cl नेगेटिव आयन्स एंड योर लुईस एसिड इन योर रिएक्शन विल प्रेजेंट एज इट इज़, क्योंकि लुईस एसिड आपके फ्रीडल क्राफ्ट एल्काइलेशन में एज अ कैटलिस्ट वर्क करता है और कभी भी कैटलिस्ट की कंसंट्रेशन रिएक्शन में कम नहीं होती। तो लास्ट स्टेप में कैटलिस्ट एज इट इज़ स्टार्टिंग वाली फॉर्म में आपका लिबरेट हो जाएगा।